Hello, grade 9 students. Okay, we are now on the topic Pythagorean Theorem. This is a topic in Mathematics 9 for quarter 3. So, the MELC proves the Pythagorean Theorem. And for the learning objectives, number 1, illustrates the Pythagorean Theorem. Number 2, prove the Pythagorean Theorem. Number 3, prove that given sides of a triangle form a right, acute, or obtuse triangle. Number 4, apply the Pythagorean theorem in finding the unknown sides of a right triangle. Okay, let us recall the different parts of a right triangle. Let us consider the right triangle below. So we have here triangle ABC. So this is the conventional way of labeling a triangle. The right angle being named as angle C, capital C, and the two acute angles are named as angle A and angle B, capital A, B. Capital letters for angles, and for the sides, the opposite of angle C is the small letter C, which is called the hypotenuse. Side AB or C. Okay, angle A, the opposite of angle A is side A, small letter A. Is one of the legs. Its name is BC or A. And we have here the side AC, opposite of angle B, so we have side B, small letter B, is also a leg. Its name is ACR B. Yeah, these are the parts of a right triangle. The longest side is the hypotenuse, C here. Okay, what is the Pythagorean theorem? In any right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. Now, in the figure above, a triangle ABC is a right triangle. A, B, small a, B, and C are the sides. Then, since side A, side B, side C are in small letters, these are the sides. So, from the Pythagorean theorem, the square of the hypotenuse, which is C squared, is equal to the sum of the squares of the legs. Side A, side B are the legs, so we have its sum. The sum of the squares, A squared plus B squared, is equal to C squared. Okay, so algebraically, this is now what we call the Pythagorean theorem, a very useful theorem in whole of mathematics. This was discovered by the Greek mathematician whose name was Pythagoras. Okay, let us now prove. Let us now prove the Pythagorean theorem. Let us have here a right triangle LMN with sides R, ST. So given LM is equal to R, here, MN, MN is equal to S, these are the legs. LN is equal to T, this is called the hypotenuse, and angle LMN is the right angle. So let us try to prove that R squared plus S squared is equal to T squared, which is called the Pythagorean theorem. The sum of the squares of the legs is equal to the square of the hypotenuse. Proof. First, let's construct altitude MK here. Okay, construct altitude MK, which is equal to W to the hypotenuse LN is equal to T, dividing it to LK, which is equal to U here, this side, and KN, which is equal to V, right? So from this figure, we have here, number 1, describe the triangles LMN, MKN, and LKM when an altitude MK is drawn through its hypotenuse. So these three triangles, LMN, MKN, LKM, these are all similar triangles. So say similar triangles, they're not necessarily congruent, they don't have the same sizes, but their sides are proportional. So reason, right triangle similarity theorem. Now let's write the proportion involving the geometric means R and S. U over R is equal to R over T. B over S is equal to S over T. These are the what we call special properties of right triangle. U over R is equal to R over T. And V over S is equal to S over T. B over S is equal to S over T. Next, let us try to cross multiply the terms of the proportion statement 2. So if you try to cross multiply this statement, R squared equals to UT. S squared equals to VT, cross multiplication property proportions. Now let us add S squared to both sides of R squared equals UT in statement 3. So it becomes R squared plus S squared equals UT plus S squared. Addition property of equality. Now let us substitute S squared on the right side of the statement 4 using its equivalent state from statement 3. So substitute natin yung here S squared as BT. So R squared plus S squared equals UT plus VT. Substitution property of equality. Next, let's try to factor the right side of the statement 5. UT plus BT has a common factor which is T. So T times quantity U plus B. Common monomial factoring. Next, substitute U plus B in statement 6 by its equivalent length in the figure. U plus B is equal to T. Here. U plus B is equal to T. Here. So T times T is equal to T squared by the product law of exponents. So from here we have proven that the square of the hypotenuse is equal to the sum of the squares of the legs, which is what we call the Pythagorean Theorem. A very useful theorem in mathematics, also in science. So Pythagorean Theorem is used in solving the unknown side of a right triangle. Find the unknown side of the given right triangle. So reminder, Pythagorean Theorem is applied only to right triangles. Okay, hindi na pwedeng apply ito sa other kind of triangles like acute or obtuse. So given, find the unknown side of the given right triangles. So let's try to solve for the x, which is the hypotenuse. The leg sides are 9 and 14. So c squared equals a squared plus b squared. Pythagorean Theorem. Substitute c by x squared, a by 9 squared, b by 14 squared. 9 squared is 81. 14 squared is 196. So x squared equals the sum of 81 plus 196, 277. Next, to solve for x, let's find the square root of both sides. So x equals square root of 277. And using your calculator, square root of 277 is 16.6 units. Yeah. Pythagorean Theorem. So of course, when we try to square both sides of the equation here, we only get the positive one because, you know, we're talking about lengths and there's no negative length, only the positive. Number 2, this time given the hypotenuse 15, one of the legs A is 9. Let's try to solve for the side B, which is equal to x. So solution, c squared equals a squared plus b squared, the Pythagorean Theorem. C is 15, A is 9, B is x. So 225 equals 81 plus x squared, transpose 81. So 225 minus 81 equals x squared, which is 144. Get the square root of both sides. Yes, find the square root of 144, which is equal to 12. Square root of 144 is 12. Therefore, side B is equal to 12. Another right triangle whose sides are x, 6, and 10. What is x? So, we're trying to solve for the value of a, which is x, b 6, c is 10. So, by Pythagorean Theorem, c squared equals a squared plus b squared. Substitute the value of b and c. 10 squared equals x squared plus 6 squared. 100 equals x squared plus 36. Transpose 36. 100 minus 36 equals x squared, which is equal to 64. X squared equals 64, therefore x is equal to the square root of 64, 8. Therefore, side A is equal to 8 units. Okay, let's have more examples. Number 1, determine whether the triangle with sides of 11.5 meters, 16.1 meters, 20.7 meters is a right triangle. So the measure of the longest side of the triangle is 20.7 meters. Let us try to use the Pythagorean Theorem. Then find the value of each side of the equation. Yan. A 11.5, B 16.1, C 20.7 meters. So C squared equals A squared plus B squared. Yan Pythagorean Theorem. Let's substitute the values of sides A, B, and C. So pag equal yan, both sides are equal. Therefore, these three sides are the sides of a right triangle. So 20.7 squared equals 11.5 squared plus 16.1 squared. 20.7 squared is 428.49. 11.5 squared is 259.21. 16.1 squared is 132.25. Add this. 428.49 is not equal to 391.46. So these sides of a triangle cannot be the sides of a right triangle. Kasi hindi nag-equal using the Pythagorean Theorem. Find the length of the brace Marcos needs for the section of pool that is 6 feet wide and 8 feet high. Yan. Let us draw a diagram of the situation. 8 feet high, 6 feet wide. Find the length of the brace. Here, the brace is actually the C. The diagonal of the what that's that rectangle. Yes, it's a rectangle. So we can solve that using the Pythagorean Theorem. A is 8, B is 6. Let us solve for C. The length of the right triangle measures 6, 8 by 8. We shall find the length of the hypotenuse. So yan, 8 squared plus 6 squared. This is 64 plus 36 is equivalent to 100. Square root of 100 is 10. Therefore, the length of the brace is 10 units. The brace needs 10 feet long. Next, the measures of the sides of a right triangle are x plus 10, x plus 3, and x plus 11. Find the value of x. Okay, let us use again the Pythagorean Theorem. Solve for x. A is x plus 3, B is x plus 10, C is x plus 11, the longest side, the hypotenuse. C squared equals A squared plus B squared, Pythagorean Theorem yan. Then substitute. C x plus 11, A x plus 3, B x plus 10. Then square the binomials. We have x squared plus 22x plus 121 equals x squared plus 6x plus 9 plus x squared plus 20x plus 100. Then combine like terms. X squared minus x squared. Okay, x squared plus x squared to x squared plus 6x plus 109. X squared minus 2x squared is 26x minus 22x. Yun, naging gano'n na yan. Simplify na. 26x minus 22x is 4x. 109 minus 121 is negative 12. X squared minus 2x squared minus 4x plus 12 equals 0. Transpose the right side's terms to the left side of the equation. Change the sign pag we transpose. So it becomes negative x squared minus 4x plus 12 equals 0. We multiply this by negative 1. The equation becomes x squared plus 6x minus 12 equals 0, which is a quadratic equation. Let us now factor. Solve this by factoring. What are the factors of negative 2? Both sum is 6. Yon, 6 and negative 2. 6 times negative 2 is negative 12. 6 plus negative 2. Hindi, 4x dapat yun eh. Can, we edit this part. 4x. Yan. Let's continue. What are the factors of negative 12 whose sum is positive 4? 6 and negative 2. 6 times negative 2, negative 12. 6 plus negative 2, positive 4. Then by zero product property, equate x plus 6 equals to 0, x minus equals 0. Then solving for x equals negative 6, x equals 2. Let us now disregard the negative numbers. It's we do not accept a negative measure of a side. So we only accept x is equal to 2. Okay. Let's now proceed to exercises. Determine the hypotenuse of the given right triangle. Okay, very easy. For number 1, what's the hypotenuse? Segment AC. Number 2 here. What is this, the hypotenuse? Segment OM. And for number 3, what is the hypotenuse? Segment DF. Number 4, what is the hypotenuse? NU. And for number 5, what's the hypotenuse? FE. Okay, hypotenuse is the longest side of a right triangle. Now determine whether the given measures of a triangle form a right triangle. Right, yes, if it's a right triangle, and no, if it's not. So, okay. Use Pythagorean Theorem to determine if these sides are the sides of a right triangle. Substitute lang. C is always the longest side. So, example, 5 squared plus 10 squared equals 12 squared, 144. 25 plus 100, 125, and 144 yan. So, number 1 is no. Ganun lang. Number 2 is still no. Here, 1, 2, 3. 1 plus 4 is equal to 9. 5 lang. Raw. How about number 3? Yes. Correct. 81 plus 1,600 is 1,681. The square of 41. Number 4 is also yes. 36 plus 64 equals 100. How about in number 5? No. The sides are not sides of a right triangle. Now for a right triangle, Joy, the lengths of two sides are given. Find the length of the third side. So to find the length of the third side, use a Pythagorean theorem. Number 1. OY is 9, JY is 12. What is OJ? Okay, we're trying to find the length of the hypotenuse. 81 plus 144 is equal to 225, so 15 ang answer. Number 2, JO is 16, JY is 9. So 256 minus 81. Then get the square root 13.2 using your calculator. OY plus JY. Okay, 16 plus 81 lang yan. Then get the square root 9.8. For number 4, 25 plus 169 is 13. 169 minus 25 is 144, so it's 12. And about number 5, the answer is 11.2 using the Pythagorean theorem. Now determine if the given sides of a triangle are right triangle, acute triangle, or obtuse triangle. Number 1, 5, 12, 13. It's a right triangle because we try to substitute the values of sides A, B, and C equal yung the squares, the sum of the squares of the legs. 25 plus 169 is equal to 169, the square of 13. Right triangle. Number 2, acute triangle. Why? Using the Pythagorean theorem, 49 plus 49 is 98. Is it equal to 8, the square of 9, 81? More than. So pag more than, it is obtuse triangle. Ito acute pala. Number 2 is acute. Pag more than, if the sum of the squares of the leg is more than the square of the hypotenuse, acute triangle. Pero pag less than, obtuse. Example, 4 plus 36. 40 is less than 49. So, obtuse triangle. Ito naman, 100 plus 144. 244. 225. Pag greater than, acute na naman yan. Ito naman, 144 plus 256. Right triangle. Okay? It's equal to 400. 144 plus 256. Now, find the unknown variable by using the Pythagorean theorem. Run your answer to the nearest 10. Okay? use the Pythagorean Theorem, and you may use your calculator to find the missing side of the right triangle. Number 1, find C. Number 1 and 2, find C. Number 3, 4, find B. And number 5, find A. So, pag find C, just add the square of A and B. Pero, so 3 and 4, pag we're trying to find B, subtract C squared minus A squared. It also with number 5, so for A, C squared minus B squared. So these are the answers: 6.6, 12.3, 10.8 for number 3, 6.8 for number 4, and 5.9 for number 5. Okay, we have also here a word problem that can be solved using the Pythagorean Theorem. Stair stringer is a board that supports stairs. Suppose a set of stairs is to rise 8 feet over a length of 15 feet. Find the length of the stair stringer to the nearest foot. Okay, by using the Pythagorean Theorem, 8 squared plus 15 squared is 289. Square root of 289 is 17 feet. Okay, thank you very much for listening. This is our lesson in Mathematics 9, Quarter 3, which is all about Pythagorean Theorem. See you next time. Bye.